we now consider how we would graph. Now we recall graphing the numbers. Remember on the table we just looked at, we had depths of 100, 80, and 62 at clock times of 10 and 20. Now I haven't labeled those clock times on the axis, and I really should. So let me grab a pen here and label my clock times as 10 seconds. And 20 seconds. Excuse my writing backwards. This isn't a good position, but you can at least probably see what I've written. Okay? So that let's think about what it means to find the slope of this line from here to here. Now you recall from your prerequisite courses, and if you don't recall, I'm defining it for you now, that a slope is a rise divided by a run. So if we go from this point to this point, we've got a rise, a vertical change in our coordinate, and a run, a horizontal change in our coordinate. The rise, if we go from this point to this point, is negative. We go negative 20 centimeters. And of course that's familiar. That is the change in depth. The run is 10 seconds, from 0 to 10 seconds, measured along the x-axis, or the t-axis in this case. And when we find the slope, we divide the rise by the run. We're going to divide the negative 20 centimeters by the 10 seconds to get negative 2 centimeters per second. And you should immediately recognize that. If you saw the previous clip recently, you should immediately recognize that as the average rate at which the depth changes. And if it's been a while since you watched clip number 3, well, it's a fairly obvious idea. We change by negative 20 centimeters in 10 seconds. That's an average rate of negative 2 centimeters per second. So that when we calculate a slope, a rise divided by a run, we're getting a rate. Similarly, the slope between 10 seconds and 80, the point 1080 on the graph and the point 2060 is negative 18 for the rise, negative 18 centimeters, and between here and here there's a 10-second run. And when we divide negative 18 centimeters by 10 seconds, as before, we get negative 18 centimeters per second. But now we see that as the slope of this graph. The slope is not quite as steep here as it is here. You see there's a slight difference. This one's a little bit steeper than this one. In general, whenever we have 2 points in a graph, we can draw what's called the slope triangle with a horizontal and a vertical side and the hypotenuse. The run is going to be delta t, assuming that it's t that's measured along the horizontal axis. The rise is delta y, assuming that it's y that's measured along the vertical axis. The slope is going to be the rise divided by the run, which is your delta y divided by your delta t, change in y divided by change in t. And that's the average rate between these two graph points.